Okay, so this is the short review on the limit definition for the derivative. So the limit definition says that the derivative of a function is the limit as delta x goes to 0 of f of x plus delta x minus f of x divided by delta x. Now if we let the value of delta x equals 0, then we end up with an indeterminate result. And we showed this to look at, we use this for functions like polynomials. And the one that we demonstrated in class, and I'm just going to do it again, is x squared. So you write out the function, then you say, okay, I'm going to evaluate this function. Instead of at x, I'm going to evaluate it at x plus this small change in x. So we'll get that. And then you just plug it in. So I want you to make sure you write all this stuff out. A lot of times people will just kind of do a half, you-know-what job of doing the notation correctly. So f of x plus delta x is the original function, but with f plus delta x substituted. F of x is just the equation, and we divide by delta x. Then you multiply out this this term. So we get, so let's just write out what this means. X plus delta x, quantity squared, that's the same as x plus delta x times x plus delta x. And then you can use FOIL. So first is x times x, which is x squared. Inner is x times delta x, and outer is x times delta x. So we get 2x delta x. And then the delta x multiplied by itself is delta x squared. Now notice I use the parentheses here, and that's because I want to show that this is just one quantity. It's not delta of x squared, it's the delta x, the whole thing squared. Now here, maybe put a parentheses around that, because delta x is not two parts. It's not delta times x, it's just the delta represents a small change of x. Okay, so once you've multiplied that out, you can plug in. So you get x squared plus 2x times delta x plus delta x squared. So that's f of x plus delta x, and you subtract f of x. And typically what happens is, the first term here and here cancel out. So you simplify it. So you cross those out. You're left with 2x times delta x plus delta x squared, all divided by delta x. And what that does is by canceling these out, it removes the indeterminacy. Well, not yet, actually, not until we cancel out the delta x's. So you gotta, don't drop this limit thing too soon. So we simplify it. So 2x delta x divided by delta x is just 2x. And delta x squared divided by delta x is just delta x. Now the indeterminacy is removed, and you can let delta x equal 0, which means this term goes to 0. This one doesn't involve delta x, so the answer is 2x. And we knew that that was the result because we've been doing these simple derivatives of polynomials. So if you remember the kinds of things that we looked at, f of x was equal to x, so f of x plus delta x is going to be just x plus delta x. Okay, that was pretty simple. If f of x equals x cubed, you're going to have x plus delta x cubed. If you had f of x equals x to the fourth, f of x plus f of x, sorry, got to put my plus delta x in here, forgot that. So f of x plus delta x is that, same down here, f of x plus delta x is x plus delta x to the fourth power. F of x is 1 over x, so f of x plus delta x equals 1 over x plus delta x. Remember this one, we had to find the common denominator. So because you'd have this minus that, but then you could get a common denominator of x times x plus delta x. That was the case of the square root of x, so f of x plus delta x equals the square root of x plus delta x. In this case we had to use rationalization to remove the indeterminacy. And one thing to remember is that when you have, say, this case right here, multiplying this whole thing out would be a pain in the neck, but if you have a plus b to the fourth power, that's a to the fourth plus 4a cubed b plus 6 a squared b squared plus 4a b cubed plus b to the fourth power. So you get 1, 4, 6, 4, 1 up here. So then, you know, if I plug that in, I'd have x to the fourth plus 4x cubed delta x plus 6x squared delta x squared plus 4x delta x cubed plus delta x to the fourth power. And then what happens if you did this, the x to fourths would cancel out when you subtract this from that. So that cancels out with that. These higher order terms are going to go to 0 when delta x goes to 0. All you're left with is this, which is 4x cubed, which we know is the answer. But, you know, if you just do the simple derivative using the formula, you get 0 credit for that. You're going to have to, when I say use the limit definition, you need to do this whole thing. Be very explicit about the whole situation.